Hello, everybody. We're on week 1 on Thursday. There's going to be a few lessons today. It's going to be 3 short lessons, 3, 4, and 5. We should have enough to get a lab done today, lab 5. Okay, before we jump into these 3 lessons, I think we should go over the workflow for this first programming project. This first programming project is called RobotCat. This is not available on our server yet. We have to download it from Canvas, and then upload it into our server. So let me go download it from Canvas. It's on our assignments, right over here. And then week 1 RobotCat. So click here. Then I'm going to go ahead and download this right here. Right? It says upload this notebook into the Jupyter. So we need to download this. It's going to put it on our local computer. So download. There you go. I finished downloading. So I need to upload this into the server over here. I want to promote a organized workflow. It might be more organized to create folders for your project. So I'm going to go in my file explorer here and create a folder called projects, just to keep things a little separate. So create a folder called projects. I'm going to click into it. And once again, as the semester progresses, projects might contain more files. So it might be a good idea to separate each project by its own directory. So I'm going to create another folder here. I'm going to call this week 1 RobotCat. Okay. You can call it whatever you want. Okay, there you go. So I'm going to go into this folder and then upload the notebook that we just downloaded. The easiest way is to click and drag. So dragged it there. This is in my downloads folder. So you can also open up your downloads folder. All right. Let me check the Zoom chat real quick. Okay, looks like people are good. All right, cool. Here's a notebook, right? This notebook is inside of a separate directory or folder. So I'm going to open it, double click. Here is our first programming project. The whole goal of this is to use the turtle library and draw this shape here. So basically, you're going to want to put the solution in this code cell here. I would probably put the name first. So the first few lines in this code cell, this is a comment. A comment is non-runnable code. We saw one type of comment a couple days ago with the hashtags, right? Like you might remember, we saw a hashtag. This is a comment. Right? This is also a comment. It's a multi-line comment. Basically, it's encapsulated in triple quotes. So yeah, just a couple different ways of doing comments. I would put name here. So Andrew space tac, that's my name. Okay. Cool. And yeah, so this is designed for folks to get outside, to get done outside of lecture. So let me know if folks need any help with it. If anything, I'll help you out with the first couple lines. We will probably need to import the library. This notebook doesn't import anything. So I'm going to go ahead and import the turtle library. I forget the exact name for it, so I'm just going to refer to a previous lesson. So I think it was in lesson 2, using the turtle. Okay, using the turtle, and here it is. Just a couple lines. This is going to import it. So copy, and then I'm going to paste it into this code cell. Then I'm just going to go ahead and run it. So press play. Okay, it's not printing anything, but hopefully folks can work on this at home. Okay. Any questions about this? Oh, I forgot to talk about submitting. So when you're done with this assignment, first of all, just make sure to save it. This circle represents unsaved changes. So make sure you save it. One way is you can go in File, click Save, or you can press Control-S, keyboard shortcut. Once it's all saved, go ahead and download it. So you can download it by going to File, and then Download. So download it, and there it is. There's a brand new copy. This is the completed notebook. And you can pretty much just click and drag this into the canvas. So there's the canvas, and when you submit it, you just click and drag. Okay, any questions about the workflow for the projects? All right, let's jump into these next 3 lessons. It might seem like a lot, but they're going to be really short. Well, we're going to have a lot of intermission, by the way. In particular, we're going to be working on Lab 5 at the same time. Lab 5 consists of a few different parts, and we're going to take an intermission between all of those parts. Pretty much we're going to do lesson 3, which will allow us to complete some pieces of Lab 5. Right, and then we're going to go back to lesson 4, and then go back to the lab, fill out some more pieces, and then finally 5. Okay, let's jump into it then. So I'm going to quit these tabs right here, and let's go ahead and navigate to our lessons directory. Okay, and the first one here is going to be lesson number 3 on literals. Okay. Cool. We can think of literals as a specific value in a program. It's like a very, it's specific because it's literal, and we can dump it straight into the program. For example, 10 is an expression. It's an expression that evaluates to the literal 10. So we can go ahead and just print this, right? We saw this on Tuesday. We were printing strings, we were printing numbers, but just to add a bit of more vocab, this is a literal. Okay, this will all come together later about why I'm using these vocabs. All right, there are a few different types of numbers. This is actually a integer literal. Integer means that there's no decimal. So an integer is like -1, 0, 1, 2, 3. Right? Those are all integers. We'll see another type of number literal. It's called a float. Right? So this is a float. A float is a fancy term for decimal. Basically, they call it float because the way it's represented in binary, there's a decimal point that's floating in between certain digits. Right? But yeah, you can think of a float as a decimal. So I'm going to print pi here. Right? 3.14 is, there we go. Okay, and I'm kind of jumping ahead. We can verify what type of things these literals are. Once again, I'm jumping ahead. There is a function called type. If we put something inside of the input, the function will tell us what type this is. So I'm going to go ahead and print whatever this type is. And it's printing class float. Okay, this is going to be important later. The reason why is because we're going to be working with data, some vague data later. So it's going to be necessary to understand what that data is represented as. Okay. Cool. I think this is pi, right? You don't have to know this, but you can get a more precise pi from another library. I believe it's math. I believe you can import something called math. And then math library has something called pi. It's I think it's math.py. So let me just print this right here. Here we go. Yeah, it's the same thing. It's more precise though. Okay. We just covered a couple number literals, in particular integers and floats, floating point numbers. All right. We can also represent numbers with a scientific notation. You might remember scientific notation is a way of representing exponents. So if we were to, one way we can represent this number here, 1 billion, this has 9 zeros. We can represent this as 1E9. Right? This is equivalent to saying 10, or it's equivalent to saying 1 times 10 to the 9th power. Oh yeah, it's up here. 1 times 10. So I'm just going to go ahead and evaluate it. All right, there we go. Evaluated. This is technically not being printed. So I'm going to go ahead and print it. All right, there we go. Okay. We can do negative exponents too. If folks have taken an algebra class, a negative exponent means it's like a fraction. So if we were to print this same thing, but with a negative 9, it's going to give us a small fraction. 1e to the negative 9. This is like saying, okay, it doesn't really show it here, but this is saying 0.000000 and then 1. That's what this is representing right here. Okay. We can put this inside of another print statement here. So I guess I'll add some inputs to this print statement. This is actually representing a nanosecond. Nanosecond is this many seconds. Then run it, Control Enter. Okay. Cool. There is a way to have Python print this with all the zeros. It's called formatting. But basically, you're going to want to put in some formatters here. We'll cover formatting some other time. It's going to be over here on lesson 8. So yeah, we'll talk about that later. Okay, that's enough about numbers. We did integers and floating point numbers. Another type of literal that we've seen is a string. You can think of a string as just text. For example, hello world. Right? Hello world, what we did on Tuesday, this is a string that consists of 11 characters. So I'm just going to go ahead and print that. Print hello world. Right. Strings are usually represented with double quotes in many languages. In Python, you can represent strings with single quotes as well. You'll see in programming that there are pretty much an infinite amount of ways to do something. So yeah, here we can represent strings with double quotes or single quotes. Yes, question.
Does it really matter if you do single or double quotes?
Good question. Does it matter if we do single or double quotes? In this case, it doesn't matter. Let's bring up a case where it does matter, though. What if we were to print, here, I'm going to make a new cell right here. So you don't have to do this. I'm going to go here, press the plus button, add another cell. All right, so someone earlier asked, is there a difference? Well, there's no difference here. But what if we wanted to print out actual quotes? Right, like what if we wanted to print out something that says, Bob says hello. Right, so you know how in literature, this hello should be wrapped in double quotes. Right, how would we wrap that? Well, if I try double quotes here inside of the string, right, so I'm attempting to wrap this in double quotes. So let's see what's going to happen. I'm going to run it. Press play. There is an error here, invalid syntax. So the Python kernel is misreading something. For folks who are curious what might be happening, it's pretty much the double quotes is representing a single string right here. Bob says, right, so that's a one string. And then there's another string here, right, an empty string. So it looks a little weird. The interpreter, the Python interpreter, is attempting to, it's thinking that hello is a variable. Right? We'll talk about variables later. But hopefully people kind of see what's happening here. Right? Basically, there's a pair of double quotes here, another pair of double quotes here. So it's not sure what's happening here. Okay, there's a couple ways we can fix this, right? With what we know so far, the easiest way is by using single quotes instead. So I'm going to use a single quote to represent the whole text. Right? So single quote before Bob, single quote here, and press play. And there we go, right? It says Bob says hello. So yeah, I hope that makes sense. You know, in some cases, the single quotes and double quotes will matter. Right? It will matter when you're trying to print these out. Okay, yeah, that's a good question. I want to go up ahead as well. So here, let me just revert these changes real quick. I just want to show another way of representing this. This is something you'll do in other programming languages. So I'm going to revert these changes. Control Z is going to revert them. Okay, so earlier we had this problem here, right? We used double quotes. There's something called an escape character. An escape character in Python is a backslash. So basically, backslash is an escape character, means to treat the next character as something special. So I'm treating this as not part of the closing string right here. And I'm also going to do it here, right? / double quote. So we're treating these as something special, meaning that the first one and the last one are the actual quotes that are encapsulating it. So press play here, and yeah, this is also another way of doing it. This is called a escape character. Okay, using an escape character to print literal double quotes. Just another way. The reason why I bring this up is because a lot of other languages will use the same format too. All right. Cool, so we just talked about double quotes and single quotes. Here, there's a couple examples on when you need to print a single quote. Like this first print statement, it's probably more necessary to use a double quote. The reason is because there is a word here that uses a single quote. So I can't do that, Dave. This is a valid string. But it wouldn't be valid if I use single quotes. Or if I use single quotes on the outermost ones, let's see what might happen. So I just replace all of it, and there is an error message. It says unterminated string literal. Once again, this is coming because Python is reading this first piece as a string, and then it says unterminated string literal, meaning that the pairs don't match. It's expecting pairs of single quotes. Right? Like here's the next one. This one doesn't have a closing pair. Okay, so let me just revert these changes back. Okay, cool. Press play. There we go. Okay, this next print statement is showing us that if we wanted to print out double quotes, then we would use single quotes to encapsulate the whole thing. So I'm going to go ahead and print that. All right, print, and then single quote, single quote. It's a good programming practice to close it immediately. So I close it immediately, and now I'm going to type in what was here, which is brevity is the soul of wit. And then space, William Shakespeare. And then press play. Okay. All right, people cool with strings so far? Okay. a couple more, and then we're going to move on to the first part of the lab. Another type of literal is true or false. You can kind of think of this as 0 or 1. So there's a literal, it has to be capital. In Python, they use capitals, so capital T, and then this will represent true. And if we print it, it's going to print out true. This is not a string, by the way. It's not. It might look the same. Right? If I were to print true here as a string, it might look the same, right? But the types are different. If I were to use that function type, and once again, there's a native function called type, which will tell us what type this input is. So I'm just gonna analyze those. Okay, so let me press play here. Right, the first type is a Boolean. A bool is short for Boolean. A Boolean is a fancy way of saying on or off. Like in binary, it's a 0 or 1. So that's kind of what true or false is. And then the second one is a string class. Okay, people might be wondering, what's the use of these literals? Well, we're going to see the use of this in the near future. Pretty much, these will determine an outcome of a program. If you've seen programming before, you might have heard of if statements, else statements. So we're leading up to something that's going to be branching. Right? Branching means we're going on to different parts of the program. Like if this is true, then do this. If it's false, then do something else. So that's what this is leading to. All right. So you can go ahead and print this print statement right here. I'm going to go ahead and try it. So roses are, and then do another input, false, violets are true. This is just an example of putting multiple inputs to a print statement. Right, in this case, we're having a string, a Boolean, a string, and a Boolean. Okay. Finally, one more literal is none. None is like saying null. It's kind of like a black hole. None is like saying nothing exists. It's not 0. It's not 0. You'll see a use of this later, pretty much in the functions lesson. Okay, we'll talk about this later. But I just wanted to introduce a few different literals. Okay. I'm curious what the type of this is. Right? Like this looks the same as the string, right? But once again, it's not. Let me just analyze the type real quick. So let me just print the type of both of these. I'm just curious. Okay, none type, and then string type. All right, once again, none type is like saying null. If you're coming from other programming languages, null is like a black hole. Okay. Okay, do this last part and then move on to the lab. So, Jupyter automatically will print the last literal as C's. So if we were to do a pair of literals here, right, this is a pair of a string and a Boolean. This is going to evaluate to, a pair. Right, so it's evaluating to this. But if we were to print it instead, it's going to be a little different. So let me go ahead and print this, copy and then paste. All right, see, it's a little different. But basically, the print statement is combining them and outputting them as roses are false. Right, but the earlier one, the Jupyter Notebook is showing the representation of of the last run statement, or that the representation of the last run statement is a pair. Or a fancy word is a tuple. Right? A tuple is a data structure in Python, but we won't really cover this too much. Okay, that's about it for this lesson. And once again, this is a really short one. I'm going to go ahead and save this. All right, so you remember this gray circle represents unsaved changes. So go ahead and save it. I'm just going to press Control S. So Control S will save it for me. Let's do an intermission, meaning let's open up the lab and work on the first part. So the associated lab with today is Lab 5. Lab 5, strings and something. Okay. It consists of a few different parts. Let's see, part 1 is on literals, part 2 is on operators, and then part 3 is on printing. Then, oh, okay, it looks like there's another part 4. Okay. We should have enough to get part 1 done. So let me go ahead and open these up again. Part 1 is on literals. So typically, labs are actually meant for folks to get done out of lecture, but we have enough time to go over this during lecture. And I'd also want to walk around and make sure everyone's doing fine. So yeah, let's see if we can get this part 1 done first. So go ahead and run this first cell. This first cell will allow us to receive feedback. Okay. It basically lets the feedback cell run. Okay, I'll help folks out with the first part. These are going to be pretty short, actually. So part 1, the goal of this part is just to type literals. For example, number 1 says type an integer literal. So you don't have to print this. You can literally just dump it out. Right? So this is an integer literal, or 1. So I'm going to go ahead and write an integer literal and go ahead and press play and go ahead and test it. Right? So the below here, this is a feedback cell. Go down here and press play. Okay, cool. All tests passed. We just wrote an integer literal. Okay, let's take a little break. I mean, not a break, an intermission. Let's see if folks can get the rest of part 1 done. So it's going to do string, a float, a boolean, Avogadro's number. Okay. I'm going to put up a 10-minute timer. For folks on the recording, see if you can give it a shot. I'm going to go over this in just a bit after 10 minutes. But yeah, please try it out yourself. Okay, I'm going to pause the recording here as well. Pause. Okay, everyone, we are back from intermission. Hopefully people gave it a shot and tried out the first part. So I'm going to quickly go through it, just in case anyone got stuck on any of these parts. Okay, we did number 1. Okay, write a string literal. This is just plain text. So the easiest way is you can just dump out text right here. Like I'm just going to dump out hello world. All right, this is a string literal. So I'm just going to press play here. Whoops. Okay. Thank you, Natalie, on Zoom. I had myself muted. Okay. Anyways, we were just going over the solution for this first part. Okay. We're here. We just finished a string cell. Let me go ahead and test it. Okay. So all tests passed. Perfect. Some folks might have printed it. Like they might have done a print statement here. You know, this is technically right, but the testing cell is being a little particular. So if I were to test it, it says I don't see a string. It's technically here, but it's being very picky. You don't have to worry too much about it. This is technically you're writing a string literal. So yeah, don't worry too much about this. This feedback is just to help out in case you get super stuck. Okay, float is a fancy way of saying a decimal. So we could do any decimal, right? Like 1.0. This is technically a decimal. Okay, and let me press test here. So test, all tests passed, perfect. Okay, and we saw earlier that a Boolean literal is like on or off, right? Or true or false in Python. So I'm just gonna put a true here. The capital does matter. Okay, so let me press play here. Press play here. Okay. Cool, so we did the Boolean and a couple more. This one's asking us to write Avogadro's number. I believe this is a decimal. So let me open this up to see what it looks like. Okay, it looks like Avogadro number is a big exponent, 6 point something, and then e to the 23rd. So I'm just going to copy paste this. So copy this decimal, right? And then you might remember from the lesson, right? You can go back to the lesson. The scientific notation can be represented with e to something. So I'm going to do the same thing, right? E to the 23rd, I believe. So there we go. We wrote it as a literal. Press play. And then let me just play this one. Cool. We're all good. Finally, we can use the type function to analyze the type of something. Or the class of something. We'll talk about classes later. Okay. So let's determine the type of true. Right? Like, what's this type? Well, you can wrap it in type function, and that'll tell us it's a type Boolean. Okay, and let me test it here. Okay, cool. All tests passed. Okay, everybody cool with this first part so far? Okay, this is going to be useful stuff. The next lesson might put it all together. It won't put everything together, but let's go on to the next lesson, which will let us do part 2. All right, make sure you save this notebook, by the way. So I already saved it, Control S. Okay, we are done with lesson 3. So I'm going to quit this tab and load up the next one. Let me navigate to the lessons directory, and then I believe we are on 4. Some operators. We can think of operators as a symbol that relates values or does math on it. So let's do some math first and then do some relationships. Okay, the first 5 symbols here, these are mathematical operators, meaning that they can produce some value. Okay. We've seen the addition operator before, right? It can work on numbers and floats, integers. You can see evaluates to 15. Let me go ahead and print it. All right. We can add integers and floating points as well. Right? Like 10 plus 5.5 gives us 15.5. Okay. So yeah, we're using this. We can also add strings together. Another word of adding strings is called concatenation. Right? This concatenation is a fancy word of saying glue 2 strings together. So I could glue hello plus world. Okay, and then go ahead and print it. Okay, cool. All right. However, we can't really mix some types. If we were to try to mix a string and an integer with this plus operator, it's going to give us an error message. Right, so 1 plus 1, it's going to say, oh, you can't mix them. Right? It says can only concatenate. And once again, concatenate means to glue. It says we can only glue a string to another string. So, one way you can fix this is by wrapping this one in double quotes. Right? It's not really a fix, but it's a way of getting rid of the error. So I'm going to go ahead and press play again. And we see that, yeah, 1 plus 1 is this right here. Right? Just to kind of do that again, what do you think is going to happen if I print 1 plus 1? But the 1 is represented as a string. Right, 1, 1, not 2. So it's just a little tricky thing, but this is a concatenation right here. Okay. Math, we can do some multiplication as well. Like if we multiply 23.2 times 10, this is going to give us what we expect. One cool thing we can do with multiplication, we can actually mix some types. We can mix a string with an integer. So let's see what's going to happen. So let me mix a string, right? Fun times an integer. Right, let's see what this is going to do. The representation, it evaluates to this right here, right? Fun 10 times. So this is just concatenating fun, yeah, 10 different times. Yeah, that's one cool thing you can do. I'm going to go ahead and print this. Okay, here we go. People cool with this so far? All right, so right. Okay. There's, subtraction and division as well. You can try that out on your own time. I do want to cover one more thing called the modulus. The modulus is like division, but it gives us the remainder instead. So let me make a new cell down here. You don't have to do this, but I'm going to make another cell. I'm just going to put a comment on it. Say example of modulus. Once again, modulus means to grab the remainder. So what's the remainder of 12 divided by 10? Right, the remainder is 2, right? Because 12 divided by 10 is 1, remainder 2. And so I'm just going to print that. Right, if I did like 16, the remainder should be 6. Okay. Cool. People might be wondering, what's the use of a modulus? There's so many different uses. One use of a modulus is to kind of restrict a range. So this is kind of going off topic again, but it's some cool stuff though. We can use it to restrict a range, or we could use it to control random number generation. It's pretty cool stuff. Here, I'm going to bring up a classic Python terminal real quick. You don't have to do this, but it's just for a quick visualization. So I'm just going to load up a Python terminal. It's the same thing, but we can evaluate things line by line. Let's see, 16 mod 10. Right, this gives us 6. 17 mod 10 gives us 7. Right, and let me just fast forward a bit. Right, 19 mod 10 gives us 9. Right, but the modulus operator, one use of it is to restrict the range. So if I reach 20 divided by 10, right, it's going to loop us back to 0. Right, and then 21 mod 10 brings us to a 1. Right. Okay, so yeah, that's one use of it. We can loop a range. In this case, we're looping from 0 to 9. Another use for the modulus is to maybe help us out with random number generation. Like, let's say you were programming a machine, or let's say you were programming something to give you a 50-50 chance of something happening. Okay, so one way we can do that is by generating a random number. Right? Let's say I generated a random number. Right, okay, I'm just going to type it in. Okay, let's say I generate a random number. How would we program a 50-50 chance of something happening? Well, one way we can do it is by modulating it, modulus it by 2. Right? This is a fancy way of saying check if it's even. So if it's If it's even, the result will be 0. Right? And let me just do another random number. Right? Okay, just another random number. Is this even? Right, divided by 2. No, it's not even because there's a remainder of 1. Right, let me just do another one. Is this an even number? Right? Yes, it is because it's divisible by 0. Right, so this is another use case. You can generate a random number and use it to program something called RNG. Yeah, it's some pretty cool stuff. Right, right here I'm just typing in a random one. You can actually import a library. I forget what it's called. I think it's called like import random or something. I gotta look at the documentation. But yeah, you can do some random number generation in rig machines. Okay. So yeah, that's modulus. We just covered a couple of math operators. There are something called Boolean operators as well. So I'm just going to scroll up real quick. Basically, Boolean operators aim to relate two values. It aims to relate two values and tell us the relationship, kind of tell us the relationship. For example, one we can do is 5 less than 3. We're relating two values, and this is going to evaluate to false. This is, once again, it's Boolean. This expression evaluates to false. Okay, I'm just gonna go ahead and print this. There's gonna be a use case for this later, by the way. Right? Once again, the Boolean operators help us branch into different areas of the program. Right? Meaning, if something is true, do something. Right? If it's false, do something else. So those will be useful later. Okay, so I'm just gonna wrap this in a print statement. Okay, is 5 less than 3? Let me just test this. It's a good programming practice to test frequently. This way we catch errors earlier on. I'm going to test this right away. Press play. Okay, cool. No error messages, so it's fine. Okay, let me do another one. I think people are getting the point, so I'm going to copy and paste this next one. Is 5 greater than 3? And then the result is right here. Right? It's going to evaluate to true. Okay. And there's some other ones too, like greater than or equal to, and then there's equal, equal. Basically, equal, equal is comparing for equality. So I did want to mention a pitfall right here. A common pitfall is to compare with a single equal sign. Here, so I just made a new cell. You don't have to, but what if I were to do like, hey, is Bob equal to Bob? Right? We would expect this to return true, but it's going to give us an error. Right? It's going to say cannot assign to literal here. Basically, a single equal sign. This is attempting to assign. Right? We'll cover this in the next lesson. But basically, it's attempting to put the right side into the left side. We meant to compare for equality, meaning that we should use a double equal sign. Right? Once again, this is a very common pitfall. The double equal sign will actually compare if both sides are true. Right? This is true. Okay, what about capital B? What about capital B? Is this equal to Bob? It's false. Okay. What about, I'm just going to print this right here. Okay, let me do another one. We can also compare strings with less than or greater than. Like, how about this? Is Alice less than Charlie? Is Alice less than Charlie? What do you think? Let me print it. Yes, it is less than that. But the reason why is because we're kind of comparing for alphabetical order. This is useful when we're sorting things. right? Especially when we're sorting strings, it might be necessary to compare them. Right? Is this less than that? So I'm going to do the same with here, right? Is Alice greater than Charlie? No, it's not, right? Because A comes before C. It's just alphabetical ordering. Okay, people cool with this? Yes, question.
So if you were to, is there a way to like basically count the amount? So like say how many letters are in Charlie, so basically to make that basically to make that statement true.
Mhm.
How would you go about accounting for the amount of letters rather than just like alphabetical word?
Yeah, good question. Is there a way to account for the length of it instead of the alphabetical? Yeah, good question. We can use the length function as well. For example, let's see. Let me just erase all of this and use a different example. So we could say something like is let me think. Hold on. Let me think of some names real quick. I'm trying to think of a good example with certain length. Give me 1 second. Let me try my name, Andrew. Okay, I see what you're saying. So someone earlier was asking, can we compare length instead of the alphabetical order? Yeah. So this is true. Can we make this false instead? Yeah, we can. We can just wrap this in the length instead. So I'm going to put this in the length function, meaning that we're comparing integers now. We're no longer comparing strings. So the length of Andrew is 6. Length of Bob is 3. So this is going to evaluate to false. That's another way we could do that. Yeah, thanks for bringing that up. Okay. We briefly talked about order of operations on Tuesday. Order of operations just tells us the precedence of things. Right? Precedence means the importance of certain operators. For example, parentheses takes more precedence. Right? It's more important. It'll be evaluated first. So yeah, if you're taking an algebra class, you might have heard of PEMDAS. This is the order of precedence, meaning that these two are different. Right? This first statement, due to order of operations, 5 times 10 is being evaluated first. So this will give us 150. Right? That this is evaluated, so 50 plus 100. Right? But if we were to wrap parentheses around the first one, this first one will take precedence, meaning it's going to be 105 times 10. They look the same, but they're different. Okay, people cool with this so far? Operators? Okay, cool. Let me save this notebook and go on to another intermission for the lab. Okay, so save, Control S. Let me check the lab out real quick. I already have it open right here. Let me see if we have enough to get the second part done. Yeah, we have enough to get the second part done. It does get a little trickier. There's going to be a bit of math involved down here. I'll go over it in just a bit, in like 10 minutes. But yeah, basically when you get to 5 and 6, it's going to say, hey, write an expression or write a program that tells us how many days there are in 20 years. Right? So just a little bit of math. And then right here, it's going to ask us about calculating how far your car can go, which depends, right? Like if we get 34.5 miles per gallon, and we have 11 gallons, right? How many miles can we go? So we'll cover this math in a bit. But yeah, give it a shot. We do have enough to get it. And What about part 3? Let me see if we can do part 3 actually. We can do part 3 as well. If you're able to do it, feel free to get part 3 done. Okay, let's take a 10-minute intermission and work on part 2 and 3 of this lab. And folks on Zoom or in person, please let me know if please let me know how things are going. All right, I'm gonna pause the recording here. Okay, we are back from intermission. Let's go through part 2 and 3 together and then move on to the last lesson for today. Okay, part 2 asks us to write a program that computes and prints the value of these two numbers with a modulus. So compute and print. So let me just get the compute done first. Right, it wants us to go 127 mod 34. Right, once again, modulus means to divide and get the remainder. Okay, in this case, it's 25. I'm going to go ahead and print it. Okay, there we go. And then let me test it down here. All tests pass. Cool. Okay, write another program that multiplies these two numbers. Okay, so let me do that. So 234.4 times 5. Okay, it looks good. Let me go ahead and print it. And then test it. All tests pass. Cool. Okay, let's do some relationships now. We're going to relate two numbers. So to determine if these two numbers, if the first one is less than that. So let's do that. 45.6 less than 34.5. Okay, that should be it. And let me just retest it. Okay, cool. All tests passed. I'm going to print it. It's usually a good program practice to print it. This way the earlier expressions don't get forgotten. Okay, cool. There we go. Okay, and some more. This one wants us to check if the product of these two numbers is less than 345. So yeah, let's check. The product of 4.2 times 45. All right, check if it's less than 345.3. Okay, I'm actually going to use parentheses around these first two numbers. I don't think you need to, but I'm going to do it for readability. Right? This readability means we're checking these first, right? Evaluating it first, and then comparing it. I don't think it matters because of the order of operations, but I'm going to put it in here. And then wrap the whole thing in a print. So wrap, print, and I don't see an operator that's necessary. Okay, so I got that one wrong. Let's see, the operator is expecting a less than or equal to. I'm using a less than. So less than or equal to, let's need the equal sign here. This means less than or equal to. Okay, let's test that. There we go, now we're good. All right, now for a bit of math. So this isn't really an algebra class, so we'll explain how these equations work. How many days are there in 20 years? Well, there's 365 in 1 year, so it's got to be 365. Whoops, I got to rerun this text cell. Made a mistake there. Rerun that. Okay, 365 times 20. And I guess I might as well print it as well. Okay, here we go. Okay, I don't see the correct result. So, really? Interesting. I'm pretty sure it's 365, right? Or was it 356? Huh, let me rerun it. 365, okay. Maybe there's an error in the grading cell. Oh, you know what? It's probably because we printed it instead. Yeah, yeah. Okay, this isn't really a big deal. It's just the feedback being picky. Okay, so there we go. A tiny bit more math. These next ones are asking us, oh, how far can you go? How far can you go if you have this efficiency, right, 34.5 miles per gallon, and you have 11.5 gallon tank? I can explain the equation behind this in just a bit. I might as well just explain it now. So efficiency is calculated by miles divided by gallon. So I'm going to go ahead and edit this text cell real quick. You don't have to edit this text cell, but I'm going to go ahead and do it. So, and yeah, you don't have to know this. I'm going to type in a different language right here. This is what math professors kind of use. Let's see. Let me just represent a fraction real quick. So efficiency is equal to miles divided by gallon. So this is miles traveled, and then I'm just going to wrap this in a fraction. Once again, you don't have to know this for this class. This is just a different language that math professors might use. Okay, a fraction, miles divided by gallons used. Okay, so the equation here looks like efficiency is equal to this fraction. So here we have two numbers. Right? We have efficiency. So this is going to be on the left side, 34.5. And we have 11.5 gallons. So this is going to be in the denominator. Right? So for folks who are familiar with the algebra, you pretty much multiply these two numbers to get your miles traveled. So yes, question. Oh, you're good, you're good. Just stretching. Okay, so it's going to multiply those two numbers. Let me see. Okay, and then press play. And let me test it. Okay, all tests passed. Looking good. Okay, this next one is pretty much the same thing, but with a different operation. It's saying, oh, hey, how much gas do you need? Right, if we need to go 200 miles. So let me just copy and paste this equation again real quick. Once again, this is not Python. This is just another formatting language. So I'm going to modify the text cell. Okay. How much gas? So we need to go 200 miles, and the car gets this efficiency. So we have the numerator, right, 200 miles, and we have the left side, efficiency. So we want to get gallons. The operation for that is division. We get 200 miles divided by 34.5. I would do this on the whiteboard, but I don't think the webcam quality is good enough. So it's 200 miles divided by 34.5. There we go. Cool, cool. All right. All right, let's move on. Now we're going to do operations with strings. Print your name 100 times using the multiplication operator. Or you might remember from the previous lesson, we can multiply strings with integer. So let's do that here. I could say Andrew as a string, and then multiply that with 100. So let me just go ahead and print that as well, because this does evaluate to another string, but I'm going to print it. Okay, print it because the directions ask for it. Okay, so print it, and then run that. Attention needed. There should be a lot of writing in the result. Okay, let me see what's up with this. Print your name 100 times. I did do that. Maybe it's because there's probably a typo in these directions. Once again, you don't have to worry too much about the feedback. Just take it with a grain of salt. It's just there to help a little bit. But I guess I'm going to get rid of the print statement and it should work. Okay, so yeah, there's just a little typo here. It says print your name, but it meant the directions meant to say evaluate your name 100 times. Okay. Write a program that concatenates 3 strings. So this is saying glue 3 strings together. So I'm just gonna glue 3 strings together. 3 strings together. Okay, let me test this. So play and play. There we go. All tests passed. All right. Okay. So as for part 3, I'm actually going to skip over this. Part 3 is asking us to print some strings. So go ahead and try this out at home. It's mostly just print statements. Part 1 is saying, hey, print this string right here. And the next part, number 2, it says use 4 print statements. So yeah, go ahead and try that out at home. But we have like half an hour left in class. So with that, let's go ahead and cover the last lesson. Let me save this real quick. So save, Control S. Okay. I'm going to exit this lesson, lesson 4, and open up the last one on variables. Okay, there we go. The last lesson for today. Yes, question. To save, I clicked Control S on my keyboard, but you can also click on File and then Save Notebook down here. Okay, is it all saved? Yeah. Okay, cool, cool. Yeah, you can tell if it's saved if there's like not a circle here. Okay. Last lesson, variables. Let's see. Just like math, variables can change. So far, we've been dealing with literals, meaning that they're like a value in your program that can't really change. So let's introduce a new topic called variables. Let me just run this cell real quick. Okay. Variable can change. In programming, you can also think of a variable as a way of storing data. Right? Storing data that can possibly change. So let's go ahead and create our first variable. I'm going to call this variable A. Right? So if we can name it whatever. Right? So I'm going to do A right here. Right? So this is actually going to be an error right here. If I were to run this, it's saying, oh, A is not defined. But we can go ahead and define it. Right? Define means make it exist. So if I put an equals 9, right, we're assigning. Right? This is called assigning 9 to the variable A. All right, so there we go. No more error. I do want to point out a direction though. It goes right to left. All right, so when we use the equal sign, 9 gets stored to the left side. Okay, and then equals, once again, this is not comparing for equality. All right, we're not checking if left is equal to the right. This is saying set the right to the left. Or, I mean, it's saying store the right to the left. So our kernel, our Python process, now has access to this variable A, meaning we can go ahead and print it now. So print A gives us 9. Right? Okay. Okay, variables can change. I'm going to jump ahead a tiny bit. Right? I could do something like A is equal to A times 2. All right, so I want to point out that the right side is evaluated first. So here, the right side becomes 18, right? Because A is currently 9. So we evaluate the right side, becomes 18, and 18 gets assigned to the left. Right, so it's 18. Are people cool with this so far? Okay, okay. Oh yeah, variables can change. All right. so we just dealt with numbers. We can also store strings. So yeah, here's an example of storing a string. I'm going to create a variable called foo. So foo. Oh, if people are wondering what foo, yeah. What does foo mean? It's like a computer technology thing. It's not really like a, yeah. So there's a analogy in computer science. It's called a foo bar baz cux. You don't have to know this. These are pretty much like in math. Right? In math, there's x, y, z. That they usually use those as variables. Uh, in computer science, they use foo, bar, baz to represent variables that don't really. That's just for trivial reasons. Yeah, that's a good one. I would actually look up foo right now on Urban Dictionary, but I might have some inappropriate results. So I would look it up after the recording. People ever look things up on Urban Dictionary? Yeah, it's a. Anyways, foo bar as I'm just going to Google it. All right, foo bar. These are. Yeah. That's probably it. They're just representing something trivial. Okay. Okay, so let's make a variable called foo. All right, I'm going to set it equal to a string. This string, it really doesn't matter what you set it to. I'm just going to set it to something. All right, it doesn't matter. This is just for demonstration. Okay, so something. Okay, and I'm going to press play. Right. Okay, I just pressed play. There's no output. This makes sense because we never really printed anything. And the value of this assignment doesn't really have a value, right? It's more like we assigned something. But you can go ahead and you can go foo right here, right? Once again, Jupyter Notebook will show the value of the last run line. And the value of this last run line is this. But I would print it because in classical programming, it's more appropriate. Classical programming isn't Jupyter Notebooks. Okay. And yeah, once again, we can put, well, we can put variables inside of print statements, right? So we can print foo is foo. This will be useful for our next homework assignment. You'll see, I'll publish it sometime next week. Okay. Let me scroll a bit. Hold up, my browser is glitching. Okay, a quick warning, variables do have to be made before they can be used. Like if I were to just put something here, like bar, right? This is just an analogy. So does bar exist? No, it doesn't exist. Right? It's not defined, so I wouldn't be able to print it, meaning that we would have to define it earlier in the kernel. So I'm going to go ahead and define it real quick. Bar is equal to, let me just set it equal to my name times 100. So bar is now a large string, and it should print that. Okay. Okay, once again, variables can change, right? Like, let's say later on in the program, I were to modify bar, like say bar is now equal to bar plus something. Once again, the right side gets evaluated first. I'm going to say it's equal to my last name times 2. So let's kind of evaluate this first. Once again, the right side gets evaluated. We're going to do order of operations, so this multiplication will happen first, and then get added to its previous result. So this is going to end up with my name and then tac at the end right here. Okay, I hope that makes sense for people so far. Okay. depending on the company that you might work at, there are stylistic preferences. Variables can have certain names. At Google, I believe they want variable names to be separated with underscores. Oh, no. Kind of like right here, right? You see how length of side, there's an underscore in between each word. This is a stylistic thing. It's basically they're using underscores. I think this is the industry standard, so I would use this one right here. Yes.
So you can do it without the underscore, right?
Yeah.
That's just what the deal is.
Yeah. Someone was asking, can you do it without the underscore? Yeah. You can. It's going to be harder to read though. Basically, your coworkers would hate you if they can't read your code. So just to go on that a bit, let me make a new cell. Yes. Oh, good question. What if we use spaces instead? Like length of side is equal to 100. Unfortunately, this is not going to work because the interpreter is going to treat the left side as 3 different tokens, and that's not going to work. It's just invalid syntax. But basically, in many programming languages, it needs to be one single piece of text. So this would work. I see no error messages here. And this is arguably harder to read. So I'm going to put an underscore here. Or another style you can do is with something called a camel case. You know how camels have humps? So this is camel case right here. Length of side. This is another style. I'm not really a fan of this too much. Right, see there's a hump in the middle and another hump here. I prefer the underscore. Okay. So variables are useful. If we have a good name for it, it will make your program easier to read. You'll see up here, right, tu.move, length of side. This is easier to read. Length of side. We will see, tu is not defined. This means we didn't import the turtle library. I guess I'll import it real quick. So I think I gotta copy it from the previous lesson. So let me copy this. Copy, then paste. Okay, yeah, we do have to import code before we can use it. Okay, there we go. All right. I guess I don't need this right here. Press play again. So once again, this is arguably easier to read because it's not a magic number. Magic numbers are numbers that appear in programs that have no explained meaning. So if I were to do something like 100 right here, right, then this is readable, but as programs get more complex, it's going to get less readable. This is a magic number, right? A magic number meaning it has no unexplained meaning. So I'm going to give it a name. Okay, this is going to make sense in a bit. Okay. Variables to hold constants. Yeah. Once again, it's going to be easier to read. So this block of code, I think we can read it. I do want to say it can be easier to be read. Yeah. This is not a good example of showing readability, but sometimes we want our turtle to change, right? Like let's say we wanted to make the triangle bigger. How do we do that? Yeah, add bigger numbers, right? We'd have to change 3 numbers. Right? We'd have to change this move, right, to like 100, and change this to 100, change this to 100. Right? That could be, and you see that was a little bigger. What if we make it bigger, right? Change the numbers again. Okay, and there we go. So this is arguably tedious. So hopefully people see it might be useful to store this in a variable so we can change things a little faster. So we make a couple of variables, right? Like length is 200 and maybe angle is equal to 120. This is going to make our program easier to modify. So let me explain. Okay, so angle. Right, so there we go. Same exact thing. If we wanted to make the triangle smaller, right, we only have to change one number. Right, like change this. Okay. Yeah. This is really useful stuff because in a lot of programs, you'll see at the top of it, there are variables that you can change. Meaning that if you change the top, then the whole, you're pretty much customizing everything that will happen below. Yeah, it's useful stuff. Okay. All right. We already went over this, updating and changing variables. Right? Just like in math, variables can change. So if I reinitialize A to 10, right, A starts at 10, so let me go ahead and print it, right, print A. This might seem weird, but this is kind of an example of keeping track of something. You can think of A as keeping track of some number, and as the program progresses, it's going to change. Right, so let me go ahead and pretend that A changed. Right, let's say that A is now equal to A plus 100. So once again, the right side gets evaluated first. So it's going to be 10 plus 100. This becomes 110. So it's going to be 110. All right, now let's change the variable again. All right, let's go A is equal to A times 2. And we should see 210. All right, let's do A is equal to A minus 50. And by the way, order doesn't matter. Right? If I were to do A is equal to A minus 50 here, right, we're not going to see the right number. Right, see how it prints 220? That's because we printed it first and then subtracted it. So the order does matter. There we go, now we see 170. Okay. Yeah, variables are cool stuff. Okay. Let's see what else. Okay. Let's see. I'm going to skip over this next part. It's pretty much repeating what we did earlier already. But yeah, I guess another key info is variables are stored in the RAM. RAM is different from storage. So you might have heard of, here, let me bring up a storage versus RAM thing. So storage versus RAM. Basically, in a lot of computers, there's something called like a hard drive or a solid state drive, right? And there's a RAM stick. Basically, if you might have built a computer before, generally the hard drive has more than a RAM. For people who might have desktops, maybe you have 1 terabyte hard drive, and maybe you have 32 gigabytes RAM. Right? The difference is the RAM stores variables for fast access, and then the hard drive stores it for long-term use. So when we run these assignments, right, A is equal to 10, it's storing data onto the RAM stick. So basically the RAM is storing A. It's not in the hard drive. Hard drive is for long-term storage, meaning that if we were to refresh or quit this notebook, then we're going to have to rerun this cell to load it back into RAM. Okay, that's just a little side note. Okay. Okay, cool stuff. It is possible to store it on your hard drive, but we're going to talk about that later. Basically, that's going to be coming up in files. Lesson 13, we'll talk about how to store things to the hard drive. Okay, let's see. So yeah, that's it for this. This last part is doing some fancy stuff with a turtle. You don't have to know about this stuff. It's just a sneak peek into something called functions and loops. You don't have to go over this. We'll cover it later. Okay, let's see. With that in mind, we have enough to get the rest of the lab done. But I feel like we should end class early and have folks try this out at home. So there's only one more part left, just part 4, printing variables. So I'll let folks try this out at home. It's pretty much practicing variables, right? Create 2 variables. Yeah, that's it for the first one. And then the next part is pretty much the same thing, but print it. Okay, yeah, go ahead and try this out at home. And if anyone has any trouble with it, feel free to let me know on the discussion forums. Okay, with that in mind, let's end early. We have 10 more minutes left in class. Feel free to stick around. Okay, for some concluding thoughts. Next week, we're going to be working with a different data structure. Next week, it's going to be something called lists. This is a way of storing multiple things at once. We'll cover that next week. Okay. Thank you, everyone, and have a good day, a good weekend.